All right. So in this section, we're going to solve radical equations. So it'll be an equation that will have a square root in it, okay, or a cube root, or some kind of root. Okay. You have to do the inverse. First thing you need to do is get that radical by itself. So you want everything else away from it. All right. And so I need now this minus 4 is not underneath that radical. Okay. So I can add 4 to both sides. So then you have the square root of x equals 4. Okay? Now, let me tell you this. Let's say that was plus 4, and we would have to subtract 4 from both sides. So then it would be the square root of x equals negative 4. Is it possible to take a square root of something and get a negative number? Is there any value I can put in for x and take the square root and get a negative number? No, that's not possible. It's impossible. So, if you ever end up with a square root equal to a negative number, you could stop right there and say no solution. You don't even have to keep going. Because technically you could continue to work it, but then your answer, when you go to plug it back in to check to see if it's an actual answer, it's not going to work. It's not going to make a true statement. Which brings me to my next statement. After you solve these, you need to go back and plug in your answer and see if it actually works. Because sometimes we end up with a quadratic that we have to factor, and so you might end up with 2 answers. Sometimes only one of those work. Sometimes none of them work. Sometimes they both work. Okay? So, we have the square root of x. In order to get rid of that square root, what do? What's the opposite of square root? Square it, right? So we need to take this and we need to raise it to the second power. But if you do that on the left, you have to do that on the right also. The square root of something squared is just itself. So now we just end up with x equals 16. Now you want to check it. You want to check to see if that answer is actually a real answer. So when you check it, all you do is go plug it back into the original equation and see if it works. So we have the square root of 16 minus 4 equals 0. See if that's true. What's the square root of 16? So you have 4 minus 4 equals 0. That is true. So x equals 16 is the actual answer. It is a solution. So just because you solve for x doesn't mean it's an actual solution. Okay? Now, sometimes they don't write the square root of x. Sometimes they write x to the 1/2 power. The same thing? Yes. Any questions? Now, let's take this same problem. Instead of writing the square root of x, I'm going to write x to the 1/2 power. And I'm going to show you why it's mathematically okay to square both sides to get rid of that radical. Okay? So, same problem. We had square root of x minus 4. So let's say that was x to the 1/2 minus 4 equals 0. Okay? That's the same thing as our original problem, right? But I'm going to leave it x to the 1/2. I'm going to show you what you have to do. So, same rules apply. Add 4 to both sides. So then you end up with x to the 1/2 power equals 4. Now, in order for us to get x by itself, we want the exponent to be 1. X to the 1 power is what we want, correct? Okay. When you take a power and raise it to a power, you multiply it, right? So, what do I need to raise that to make this 1/2 turn into a 1? A 2, because 1/2 times 2 equals just 1. So that's why it works when you square it. That's how come the square root of something squared equals itself. But if you do it to the left, you have to do it to the right, because 1/2 times 2 is just equal to x to the 1 power. That's the reason why you do that. Okay? And so equals 16. Okay? So, if you ended up with a problem that looked like this, x to the 2/3 equals 5. We got to raise both sides to something to get this x by itself. What am I going to raise it to? 3/2. Because that's the only way you can make this exponent turn into a 1. When you raise it to 3/2. Because now you have 2/3 times 3/2, which is 1. Make sense? But if you do it to the left, you have to do it to the right. So now you just end up with x equals, and you use your calculator, and you do 5 to the 3/2 power. And you round it to the nearest hundred, so it's 11.18. Okay? Okay, one thing I need to mention. When you have to raise it to a power, a fractional exponent to get rid of it, okay? You're actually, to the 3/2 power is actually the square root of that to the 3rd, right? The square root of that to the 3/2 power, x to the 3/2 power. Okay, so I was saying, x to the 3/2 power, if I wrote that using a radical, that's x to the 3/2 power. It's actually a square root, right? Okay. Remember when we solved the equations, we said if you take the square root of both sides, what you always need to remember what? If you take the square root, very good, the plus or minus. If you take an even root of both sides, you always have to remember the plus or minus, correct? Brianna, don't pay attention. So, if you're raising this to the 3/2 power, that denominator tells me that's an even root, okay? So, if you're raising it to a power that has the denominator is even, you have to consider the plus or minus. Okay? If that denominator is odd, then you don't. So this technically would be plus or minus 11.18. Because if I took 11.18 and plugged it back in here for x, the positive case would work and the negative case would work. Okay? So let's move on. This is what we just did. 2x to the 3/2 equals 250. Okay? I have to get x by itself, right? What do I do? Very good. Divide both sides by 2. So you get x to the 3/2 equals 125. Now I have x to the 3/2. I don't want that. What do? Raise it to the 2/3 power. Raise both sides. You have to do it to both sides for it to stay equal. Now, I raise it to the 2/3 power. Do I need to consider the plus or minus? Is that an even root or an odd root? That's an odd root, so you don't have to consider the plus or minus. You only have to consider the plus or minus when it's an even root. And this denominator, I don't care what the original problem is, I care about what I'm doing to it. Okay? And so this denominator is odd, so I don't need to consider the plus or minus. And so now these cancel each other because when you multiply, you get 6 over 6, which is 1. So that's x to the, do 125 and raise it to the 2/3 power, 25. Any questions? All right. Let's do this. Now we've got more underneath the radical than just x. The rules are still the same. You have to get that radical by itself. Now, step 1 in this problem is to do what? Subtract 2 from both sides. So I have the square root of 4x minus 7 equals 3. Can I add 7 to both sides now? No, can't. It's protected. It's in witness protection. You can't touch it till you get rid of that radical. You can't get rid of that radical until you do what? Square both sides. So remember, we can do this because this is the same thing as 4x minus 7 to the 1/2 power, right? So that's the reason why that works. So you just end up with 4x minus 7 equals 9. Now, if you're just squaring both sides or cubing both sides or raising both sides to the 5th power, you never have to worry about plus or minus. It's only when you're raising it to a fractional exponent, because then you're actually taking the root of it. Okay? Yes. So now once you square both sides, your radical's gone. Don't write it again. Okay? And so now it's just a regular problem. So add 7 to both sides. So 4x equals 16. Divide by 4. And x equals 4. But does it? Does it equal 4? We got to check it. You have to check to see if it's right. You have to check to see if x equals 4 is an actual solution. Plug it back in and see if it makes a true statement. So you have the square root of 4x minus 7 plus 2 equals 5. The square root of 4x minus 7, was it plus 2? Let's see if that does in fact equal 5. Okay? So we have to plug in 4. So 4 times 4 minus 7 plus 2, does that equal 5? We're checking to see. So that's 16 minus 7 plus 2 equals 5. 16 minus 7 is 9 is 3. So 5 does in fact equal 5. So yes, x equals 7 is the solution. Sometimes you do that and you get a false statement and then there's no solution. Okay? Any questions? Okay, let's look at this one. So we have to solve for x. Now, I've got an x over here. I could get it by itself, but then I still have an x over here that's trapped underneath that radical. My focus needs to be on this one. Okay? I have to get rid of that radical. So what do? What? No, not yet. I can't. This x is protected underneath here. So I have to get it out from that radical before I can start combining anything. So we're going to square it. But if I square the left, I have to square the entire thing on the right. I have to square the whole thing on the right. Now, Is that x squared plus 4? No, it's not. This is x plus 2 times x plus 2. So this, on the left, this just gets rid of the radical. The radical and the squared cancels each other out. So I have 8x plus 1 equals. This is x plus 2 times x plus 2. Do not make the mistake of squaring each term. You have to square the entire left-hand side, and then you have to square the entire right-hand side. Okay? So x plus 2 times x plus 2, what do I need to do with that? Distribute. So I have 8x plus 1 equals x squared plus 2x plus 2x plus 4. Now, you see a squared term, right? When I combine my like terms, I'm going to have to set everything equal to 0 and factor that using either the AC method or whatever method you use. Okay? Because that tells me I'm going to get 2 answers. The squared term tells me I'm going to get 2 answers. So I combine my like terms over here to simplify it. So I have 8x plus 1 equals x squared plus 4x plus 4. Now, I'm going to leave my x squared over here because it's positive. I don't want to move it to the other side and make it negative, just to put it on the left. I'm going to leave everything on the right. And so I need to get rid of x times x. Okay? So I need to subtract 8x from both sides, and then I got to get rid of that too. So what do? I got rid of this. Now I need to get rid of that. Subtract 1. So I end up with 0, which is what I want, equals x squared minus 4x plus 3. I'm solving for x. I have a quadratic there. I need to factor that. Oh, I got rid of everything on the left, so I subtracted 8x from both sides, and then I subtracted 1 from both sides.
So it's negative 1 and 3.
No, negative 3 and 1. So 0 equals. Okay? Factors that multiply to equal 3, but combine to equal negative 4, negative 1, and negative 3. What's the next step? Set each one equal to 0. So x minus 1 equals 0, and x minus 3 equals 0. Trying to find my 2 solutions, possible solutions. So, add 1 to both sides. Add 3 to both sides. So you get x equals positive 1 and x equals positive 3. Those are your possible solutions. You have to check to see if 1, both, or none are solutions. So you have to go take x equals 1 and plug it back in and see if it works. Take x equals 3 and plug it back in and see if it works. When you do, you will see that both of them do work. So we have x equals 1 and x equals 3. So x equals 1, that's the square root of 8 plus 1, which is 9, right? So that's square root of 9 is 3. So when I plug in 1, I get 1 plus 2, which is 3. So you get 3 equals 3. So x equals 1 works. Did y'all follow that? I plugged in 1. 8 times 1 is 1 plus 1 is 9. Square root of 9 is 3. 1 plus 2 is 3. 3 equals 3. That one's good. And then you plug in 3. 8 times 3 is 24. Plus 1 is 25. Square root of 25 is 5. Huh? You got it? And then 3 plus 2 is 5. So you get 5 equals 5. So both solutions work. That is as complicated as these problems get. Okay? When you have to square both sides and you end up with a binomial on the other side, so you have to expand it and distribute and then factor. Okay? Any questions? Is anybody not finished with this? All right, let's look at another type of problem. What if you have two radicals? Well, if you take a radical, like a square root, and square it, it gets rid of the radical, right? Right? If you take a square root and you square it, it gets rid of the radical, correct? Okay. So, but when you square it, you have to square both sides, right? So wouldn't it be convenient if you had that square root on both sides? Then you square both sides and get rid of both radicals at the same time. That's what you have to do. When you have more than one radical in an equation, you have to move one of them to the other side so that when you square both sides, you get rid of both radicals. So, how many terms do I have here? 1, 2. Terms are separated by pluses and minuses. You can't count the one underneath the radical. It's protected. So, if I want to take this minus 2 square roots of x and move it to the other side, what would I do? Plus 2 square roots of x, correct? So if you take this and bring it over there, it becomes a positive 2 square roots of x. That's just like minus 2x. You move it over there, it becomes plus 2x, right? So you have the square root of 3x plus 2 equals 2 times the square root of x. It became positive when I moved it over. Now, I can get rid of my radicals in one step by squaring both sides. So, no, because anything plus 0 is just no, so don't worry about that. So we're going to square this side, we're going to square that side. The number outside of the radical just simply gets squared. Okay? So, but you can put that in your calculator. All right, so over here, if you take a radical and square it, you just end up with what's underneath. So 3x plus 2. Now, 2 squared is 4. The square root of x squared is x. So that's just 4x. Because I took this and moved it to the other side. So it became positive 2 square roots of x. Okay, like if you did this, let's pretend like this was no radicals. 3x minus 2x equals 0. Let's say I wanted this over there. I would do plus 2x. Yes, because you moved it over to the other side of the equation. This is what I did. So 3x plus 2, let me rewrite it. Minus 2 square roots of x equals 0. I added 2 square roots of x to both sides. And that canceled it from the left. Does that make more sense? Okay. And so then you end up with square root of 3x plus 2 equals 2 square roots of x. Okay? I moved that whole term over to the other side. Okay, so now it's just a regular problem. So we'll subtract 3x from both sides. And you end up with 2 equals x. And then you want to check it. You want to check it and make sure that that solution works. So when you check it, I'm going to plug in 2 for x. So the square root of 3 times 2 plus 2 minus 2 times the square root of 2, does that equal 0? So this is the square root of 6 plus 2 minus 2 square roots of 2 equals 0. So that's the square root of 8 minus 2 square roots of 2 You're checking to see, does that equal 0? Y'all tell me. They're waiting for me to tell you? It does. Square root of 8 simplifies the 2. So, but if you calculate that, you'll see that 0 equals 0. So it checks. So that means that was an actual. It worked. Okay, I want you to try these. So you're going to square both sides. So now this is x minus 4 times x minus 4 equals 2x. So now we're going to distribute. So that's x squared. That after you distribute and combine your like terms, you end up with minus 8x plus 16 equals 2x. We need to set it equal to 0 so we can factor it. So subtract 2x from both sides. So you have x squared minus 10x plus 16 equals 0. Okay, so we factor that. The factors that multiply to equal positive 16, but when you add them, they equal negative 10, are negative 8 and negative 2. X minus 8 equals 0, so x equals positive 8. X minus 2 equals 0, so x equals positive 2. Now, you have two possible solutions. You have to check to see if they work. If you did that correctly, you would see that x equals 8 works, but x equals 2 does not work. If I plug in 2 right here, I'll have 2 minus 4, which is negative 2. So then you end up with a negative 2 equals the square root. Can't happen. X equals positive 2 doesn't work. But when you plug in x equals 8, that's 8 minus 4, which is 4. And then you have the square root of 2 times 4, which is 16. Square root of 16 is 4. So x equals 8 works. Now, we were talking about number 2. If you looked at it and recognized that this is the even root can't equal a negative number. So I know my answer is going to be no solution. But let's actually work it. If you worked it, if you checked your answer, your one answer that you got didn't work, so there's no solution. So we raise this to the 2/3 power. When you put that negative 6 to the 2/3 power in your calculator, you need to make sure that negative 6 is in parentheses. If you don't put it in parentheses, if you put a negative number to any power, it's always going to make your answer negative if you don't put parentheses. So that ends up with x equals, you get 3.30, okay? If you check it, 3.3 to the 3/2 power, does that equal negative 6? No, you end up with positive 6 equals negative 6, which is not true. So there's no solution. For the last one, we need to get this by itself. So we're going to add 1 to both sides. So you have 2 times the square root of 7x plus 4 equals 8. You have two options right now. You can square both sides. And if you square both sides, you would end up with 4 times 7x plus 4 equals 64. There's nothing wrong with that, okay? But what you should do, I told you to get that radical by itself. So we have 2 times the square root of 7x plus 4 equals 8. Get that radical by itself, so divide both sides by 2.
I like the reason. It was wrong.
No, there was nothing wrong with it. I erased it just so I could do the second option. So 7x plus 4 equals 4. Now my radical is by itself, so now I can square both sides. So now you just end up with 7x plus 4 equals 16. And that's just a simple equation, a two-step equation. 4 squared is 16. So subtract 4 from both sides. 7x equals 12. Divide by 7, and x equals 12 over 7. Okay? And if you checked it, it would work. Now, if you might have written that as a decimal, so x is approximately equal to 1.71.